Probably you've all heard of this question, or sometimes it's stated as if it's a fact that we are in the sixth mass extinction, or sometimes it's asked, are we in a sixth mass extinction? Is this a well-posed question? Does it have value to ask such a question? And what would be the challenges of answering such a question? Of course, when you say sixth mass extinction, there is an assumption that there have been 5 mass extinctions, and people have their own sense of what this means. They may be thinking of dinosaurs and a big meteorite crash, and they may think every past extinction has had similar impact, similar extent of loss of life or species, or do they think it's a loss of biodiversity? So these are some questions that are normative as well as scientific, and they have to be asked, especially whether to see if we have asked this question as a good starting point to raise questions about our impact on other species on the planet, and then have we now reached a stage of a doomer. There is climate deniers, and now there is a new term called climate doomers. These are people who believe in climate change. Often they are climate scientists who tend to resort to alarmist language about how many years we have left to save ourselves, save the planet, etc. Considering the planet is not going anywhere, biology is not going to go extinct, we have to be more subtle about our message. So keeping all these in mind, there is a paper that's coming out soon in the Journal of the Philosophy of Science. So philosophers are good for asking such questions about what is the value of such a question and what are the challenges. We'll see some explanations or some caveats and some historical context about the challenge of answering such a question, or the challenges of answering such a question. It's a lot of text, but I'll read it because this question also interests me. In general, I'm a bit concerned about raising the alarm about climate change as a end of the world message, because this is creating a so-called lot of climate anxiety. A lot of young people are feeling hopeless, and you cannot bring about good action, mindful action, from a place of fight or flight. Best actions come, mindful actions come, especially for the future when you are in a rest and digest state, or the sympathetic nervous system instead of the sympathetic nervous system. So without going too much away from the main message, the abstract of the paper partly reads this way. In both scientific and popular circles, it's often said that we are in the midst of a sixth mass extinction. Although the urgency of our present environmental crisis is not in doubt, such claims of a present mass extinction are highly controversial scientifically. Our aims are first to get to the bottom of this scientific debate by shedding philosophical light on many conceptual and methodological challenges involved in answering this scientific question, and secondly, to offer new philosophical perspectives on what the value of asking this question has been, and whether that value persists today. So it started a while ago. You'll be surprised how long ago this debate started. So it's not something that happened very recently. So that means when it started, did it have value, and how that has changed as we went along. And in fact, as global warming has become more and more obvious and our impact on the planet has become more and more quantified, we show that the conceptual challenges in defining mass extinction, uncertainties in the present diversity assessments, and data incommensurabilities undermine a straightforward answer to the question of whether we are in or entering a sixth mass extinction today. More broadly, we argue that an excessive focus on mass extinction framing can be misleading for present conservation efforts and may lead us to miss out on many other valuable insights that Earth's deep time can offer in guiding our future. So past mass extinctions are studied by many paleoclimatologists, paleontologists, geologists, climate scientists, and so on, to understand what caused them, how extensive they were, and what their consequences have been. And we'll discuss this elsewhere in other courses, but this is a very specific question about asking the question of whether we are in the midst of a sixth extinction. So looking at a brief history of the sixth mass extinction debate, I'm just taking a small chunk of this section here. Surprisingly, the actual section in the paper is much longer. Surprisingly, the history of the sixth mass extinction idea is almost as old as the coining of the term mass extinction itself. Our modern understanding of mass extinction is indebted to the work of John Phillips, who lived from 1800 to 1874, nephew and apprentice of William Smith, who undertook the project of compiling as much data as he could find on an extinct taxa and organizing them on extinct strata, not on an extinct taxa. Sorry, I'm having a little bit of an afternoon daze here, sorry. And organizing them according to the geologic time. Phillips' Life on Earth, Its Origin and Succession was a milestone in three respects. It contains the first geologic time scale, the first paleodiversity curve, which we'll see in a minute, and the first application of data correction methods to address biases in the fossil record. That's pretty stunning considering how old the book is. In this chapter, Varieties of Forms of Life in Successive Periods, Phillips counts the number of fossil taxa in the Paleozoic, Mesozoic and Cenozoic. You can look up these geologic periods in my other podcasts. And notes that raw fossil taxon counts are biased by the differing amounts of sedimentary rock corresponding to different periods of time that happen to be preserved and are available at outcrop. More rock, more fossils, and a bias paleontologists still struggle to correct today. So when you go in geologic periods, you're looking for outcrops that are available with fossils that are available in those outcrops, and depending on the Earth's history and what else has happened along the way, some periods are better preserved than others, so you end up with counting fossils and trying to infer along with other evidences like the iridium layer for the dinosaur extinction to figure out what caused the extinction and how many species may have disappeared, etc. So that's obviously quite a big challenge. Remarkably, Phillips goes on to adjust or correct the raw paleodiversity numbers by determining a relative number of species to be expected on average in a given thickness. As historian David Sepkoski notes, this is one of the earliest examples of bias correction which we now do routinely for forecasts and projections, climate forecasts and climate projections. So big bias correction in the history of analytical paleontology. Moreover, Phillips uses this method on two different data sets, obtaining largely the same results. So sampling issue, interpretation issue, biases, bias corrections are all some things we cannot ignore here. So this is the first known paleodiversity curve by John Phillips from 1860, representing the waxing and waning of marine fossil taxa and revealing the end Permian and end Cretaceous mass extinctions which he used to define the Paleozoic and Mesozoic era. Figure available in the public domain. Okay, so you can see this is time going forward. So Paleozoic, you come forward, there have been some dips, and then there was a mass extinction, and then there was an explosion of species or families, and then another mass extinction, and then so on. And people will see another curve which has argued that after each mass extinction there is an increase in biodiversity or number of species, number of families. It depends on how you count. In general, when you look for past biodiversity, you look for families, because even if one species is present from that family, you can interpret that that family to which the species belongs was present at the time. So it simplifies things in some ways. This debate about whether we are in the midst of a sixth mass extinction has not abated. In 2020, conservation biologists Gerardo Ceballos, Paul Ehrlich and Peter Raven confidently assert life has now entered a sixth mass extinction. Paul Ehrlich is the same one who had claimed that we are going to have a population bomb back in the 1960s or early 70s, which didn't come to be because of the Green Revolution. So we have to be always mindful about people's interpretations of the future as well. However, even sympathetic biologists such as paleoecologist Anthony Barnowski and colleagues write, the recent loss of species is dramatic and serious, but does not yet qualify as a mass extinction in the paleontological sense of the big five. So if you compare to the past extinctions, we are not in the midst of it, or we are not entering a sixth mass extinction according to some paleobiologists. Similarly, invertebrate paleontologist Douglas Irwin remarks, many of those making facile comparisons between the current situation and the past mass extinctions don't have a clue about the difference in the nature of the data, much less how truly awful the mass extinctions actually were. I do think that as scientists we have a responsibility to be accurate about such comparisons. This is also true for global warming and its impacts, and interpreting every weather event as because of global warming and keep saying these things will get worse and worse because end justifies the means is never a good approach in science, right? What then are these differences between paleontological and ecological data? What exactly is a mass extinction? In the following sections, we lay out and assess the many conceptual, methodological, and didactic challenges that must be resolved before such comparisons can be responsibly made. So if you have issues with data in the past and sampling issues as well, then is there really a definition of mass extinction? Is there a solid context in which you are counting extinctions and saying we are in the middle of a sixth one? That itself is a serious issue as well. So this is the curve that shows number of families. As I said, we count families with geologic time going back from about the Cambrian explosion or just before to the various geologic periods and the so-called five extinctions: late Ordovician, loss minus 12%, late Devonian, late Permian, late Triassic, and late Cretaceous. And you can clearly see the increasing number of families to the present. So that has to be explained as well. The Sepkoski curve representing marine diversity at the taxonomic level of families over the last 600 million years. The big five mass extinctions are labeled at the troughs of the diversity curve with relative magnitude of drop given in parentheses in the upper left here. So you can see late Permian number 3 here counts as one of the biggest ones in terms of the number of families dropping. So how do you compare these, and how do you compare where we are currently, and what does it mean if there is always an explosion of diversity in number of families after the mass extinction? Does that mean the event that caused it opens up new niches and new species take up those environmental niches to fill in the gap? And does this mean over time the biodiversity will continue to increase even if we create a sixth mass extinction? So these are critical questions. Reading some more text, a few years later, Sepkoski offers the following theoretical definition. A mass extinction is any substantial increase in the amount of extinction, i.e. lineage termination, suffered by more than one geographically widespread higher taxon during a relatively short interval of geologic time, resulting in an at least temporary decline in their standing diversity. So there has to be a time within which it happens, has to be geographically widespread, and so on. So we are struggling with these rules, right? 5 mass extinctions. Baumbach and colleagues here propose the generic term mass depletion instead of mass extinction, and argue that only 3 of the big 5 qualify as mass extinctions per se, leaving the other 2 as mass depletions. So this debate is legitimate and still going on, and we have to keep that in mind when we use the word descriptor sixth mass extinction. When originating an extinction data are compared for the big 5 mass extinction events, only 3, the end Ordovician and Permian and Cretaceous, appear to be unambiguous extinction driven global events. The other 2, late Devonian and the end Triassic, are as much a product of attrition from the reduced origination as they are of elevated extinction. So there is always species origination and extinction happening. So what if it's not really extinction but just a slowdown in the species origination, and it shows up as a drop in number of families, for example, right? These are critical questions. Okay, in this limited sense, there are just 3 unambiguous mass extinctions. So keep that in mind. Looking at the table here, I hope I didn't reverse it. Yes, I did. So these are the authors here and the number of mass extinction. You can see one counts only 2. That was Phillips when he started the debate. Noel counts 8, including the current one. So he's got 2 more in the past. 4 to 5. 4 are statistically significant in this work. Sepkoski then says 5. Bombach says 3 by consensus, or 18 on Sepkoski definition. So he reapplies Sepkoski definition for the past and comes up with the number 18, and then Racki in 2021 says only 2. So far from there being a consensus on the big 5, different researchers have counted different number of mass extinctions depending on which criteria and definitions they use. So this is also worrisome. Coming closer to the conclusion, in conclusion we offer a brief reassessment of the value of asking, are we in a 6th mass extinction? Historically, the concept of a mass extinction has been immensely valuable for paleontology by focusing attention on a handful of key episodes in the vastness of geologic time and leading to numerous insights about the nature and dynamics of evolution, geology, the climate system, and their various interactions. Okay, so there was value in asking such questions about past extinction events as noted in geologic evidences, paleontological evidences. Moreover, mass extinction studies have taught us that catastrophes do indeed happen and that ecosystems are not infinitely resilient. Species arise and they are living in an environmental region, and if there are huge perturbations to the climate, or like a meteorite strike, massive dust storm thrown up by the meteorite crash, for example, or plates move and you are cut off from the upwelling regions and so on, then it is easily understandable that mass extinctions or large number of species do disappear. Moreover, mass extinction studies have taught us that catastrophes do indeed happen and that ecosystems are not infinitely resilient. As mass extinction studies have progressed, however, there has been a growing recognition that the various events in geological history grouped together under this label are in fact heterogeneous. They are not single typology. For example, the mass extinction framing led to the presumption that there is a single unitary event to be explained, an assumption which, as we saw, has often been overturned. Some even argue that we might call the mass extinction framing is now more likely to mislead than inform. Okay? For instance, this framing can tempt researchers to suppose that all mass extinctions have a common cause. Then he goes on to give examples of how different authors have counted different number of extinction events themselves along with the causes. Finally, similarly, one can argue that more specific 6th mass extinction framing was also initially useful. There's a bit of a breeze again, so I will see how bad the sound is. You get the hissing sound. Hopefully it's not too bad. Similarly, one can argue that more specific 6th mass extinction framing was also initially useful, not only in gaining the public's attention, but in demonstrating the importance of looking to Earth's deep past for guidance about our future. This is paleoclimate, paleontology are like a rear view mirror. When you're driving forward, you have to always be aware of what's happening behind or what may sneak up on you. However, it too arguably outlived its utility, being more likely to mislead than inform. As the PETM case illustrates, the Paleocene-Eocene thermal maximum illustrates, there are many more lessons to be learned from the deep time for guiding our future and helping us address planetary crises today than are just to be found in the mass extinction episodes. Paleocene-Eocene thermal maximum is one of the rapidest warming rates, with the amplitude being one of the largest around 55 million years ago. What does it say about the potential for future warming and the tipping points in the system potentially? And how fast was that warming compared to the warming rate at present? More broadly, the ability to contextualize our own experiences and actions in the vastness of geologic time, while still appreciating the ability of humans to significantly affect Earth's systems at global and long-term scales. It's an attitude that geologist Marcia Biernow calls timefulness. We believe that adequately addressing our biological and environmental crises today is going to require embracing timefulness in this broader sense. Furthermore, increased collaboration between conservation biologists and paleontologists for this purpose will be needed and may be facilitated by setting aside the controversial sixth mass extinction framing. In sum, although determining whether we are in a sixth mass extinction is a fraught question due to the conceptual, methodological, and didactic challenges discussed herein, asking these sorts of questions more broadly enables scientists and the public to better situate themselves in geologic time, a perspective that will be increasingly necessary to confront the obstacles to come. Okay, so let's leave it here, but you get the idea that the point of this podcast or the paper is not to deny anything, but to understand the value of asking this question and be aware of the challenges of answering it correctly, and not just using it as using it as a sledgehammer. Media tends to pick up on these key terminologies and then keep using it without proper background, and that can be a problem in terms of just mass perception. Okay, that's the caveat of this paper, and I hope I summarized it well enough for you to understand the points. You should of course go and read the paper. It has some very nice references as well, and there's more details than what I have presented in this brief podcast. Okay.